How's it going, everyone? Welcome, Eulir Gonzalez here again, looking now at the Redux fundamentals as a way to understand now what is the problem that this particular tool solves, how it works, what is the inner mechanism, and also put at practice all of this inner mechanism. How can we build this machinery as a part of this other course, which is now the Advanced Redux. The TLDR of this is that now Redux provide now a convenient way or a best, so it now provide a middleware, something that we're going to talk about that in today's video, that it allow us to simplify some of the process that we have to do when we use plain Redux. Okay, so it simplify a lot of the ceremony that we have to do when we need to update our states. Following is the Flux architecture, the Flux architecture, and it also provides more TypeScript support, as well as the ability to easily integrate now middlewares without actually having to Google about how to do that, right? So because of that, in today's video, we're going to now look at the middlewares and then how can we hook it up with React. And of course, and we're going to have also a more hands-on approach with coding. So the TLDR of Redux is that now we're not going to see this well-battled test state management, but also we're going to recap about what does it mean, especially with Redux. The problem that we are facing here, especially as we create no user interface as well as the server, because this is something that wherever you need to manage a state, wherever you need to manage data, you need a mechanism or a pattern that allow you to make it much more easy to do, as well as maintainable and readable. So the TLDR of this, the problem that this Redux is trying to solve, is about state mutations. So if you have now a particular data, anytime you mutate your data, you want to know what happened. Okay, so this is part of the Redux goal and intent. When they describe is the that has influence from Redux, from Flux architecture, that is, well, they're going to now make the state mutations maintainable as a top priority, and by following is this Flux architecture as a way to make those state update logic maintainable, all right, and provide some developer tools that are easy to debug and test. We follow is now the certain functional programming, certain constraints for that, immutability, serializability. And also, if you have now an asynchronous behavior in your application, for example, fetching data from the server or waiting for a user response, okay, any async behavior must be kept separate from the act of updating your state. And also, well, how we can now integrate all of this update logic into one single reducer as a way to now is make it easy to know the data flow as well as what are the state that we want to update. So this is part of the intention or part of the design and the goal of Redux is to, hey, let's going to make the state update management or the state mutations maintainable as a top priority by using Flux architecture. And also let's going to now use some of this. We want to make also the the action, the state of mutating your applications much more streamlined, which means is that all of these actions that you are triggering, we need to actually find a way to make them semantic. So they have no semantic meaning when you're triggering actions. And also make your update logic here easy to follow, easy to read, and easy to understand. By applying some of these functional programming concepts, such as immutability, so purity, immutability, as well as so purity, immutability, curing, partial applications, as well as monad, just to mention the most relevant for this tool, right? If you want to now update your, if you want to have asynchronous behavior, you can do that, but separately from the act of updating your store. Also, it's going to make the API, this Redux, this library, small as possible and extensible. So this is now the design. This is based on the Mark recommendations, which is one of the maintainer of Redux. So with that perspective, right? And remember that after all, that's the problem that we're trying to solve here as a software engineer, okay? Especially here with UI. So far we have looked at what is this thing made of. This Redux, which is after all is an object that have a series of functions attached to that. So the shape of this is like this. So you have that dispatch. As you can imagine, this actually is going to trigger that particular action that is going to call the reducer or the update logic that is going to now is mutate or create a new state that has this new change. The get state, right? Replace reducer, subscribe, and then we're starting to see now is some of the components of this Redux. So for example, compose, which is a great function that allows you to write, is to run as a way to, well, compose is function input with function output to get one single output. So as a way to now pass this through a series of phases of the supply chains. So you can imagine this like a motorcycle, right? When in each particular phases you have now the blueprints and then the materials, and then now is let's say the frame. So put in the frame, and then also the electrical system, for example, and so on and so forth. So each one of them has that particular phases. Another good example is, for example, when you ask for an ice cream, you say, hey, I want 3 flavors. I want mocha, Oreo, and lemon. You shouldn't mix that, but in any case, you have some wild taste. That the idea is that as you see that the seller is putting all of these bowls of ice creams into that cup, you can think of this that is phases that is going to compose, or this composition of actions that is composition of functions, composition of set of instructions that you tell them, okay, to do that, right? Okay, so with that, one of the things that we can, another thing that we look, which is besides the compose, we also look at the create store that actually is returning this particular object, which is great, and some of the way of how you can define is the actions, how you can use the Flux architecture as a way to, well, update the state. So we look at the actions follows a particular format or object notation, right? And how error prone is to actually create an object every time. So we use this now as functions, and then we call them is create actions. So this particular function are very easy to test and to check, all right? So this is something that we're going to pass now to something called, which is part of the API, the bind to actions, right? This binding to actions, right, which is also, we look at the subscriber as a way to understand this particular anatomy of that. What is this patch is doing, what is subscriber, what is the reducer, and this bind actions creators. So what it's doing behind the scene is that bypassing these functions that return is and actions, and the way to do that is because it is much more easy for us to test that, right? So now we can behind the scenes, what it's doing, or I'm assuming that this is what it's doing, is that call decompose. The last argument is the functions from all of those actions created that we pass, and the output will be the input from the store.dispatch. And they're gonna provide you now the proper actions that is going to dispatch or call that dispatch function in the Redux store. So far so good, because as we move on, then we look at the combined reducers. This is something useful, especially if you want to now have specific logic, the update logic in their own separate model, their own separate function. Okay, so this is the update logic for, let's say, user, for, let's say, orders, for the products, right? Especially if you're building an e-commerce. So the idea here is that by using the combined reducers, you are going to pass all of these reducers that is going to now have all the necessary update logic for that state. So far so good. And then we look now at the enhancer, which is now a property from it's an argument from the create store. This allows us to now enhance, the word is still descriptive, but the core functionality of the Redux. So it only runs when the application is created or when the function is called. And then you can now is, for example, define here things like logging when an action is dispatched, or monitoring how many times this particular application is or this particular action function is triggered. You know, also here, this is when you define is the dev tools, right, as a way to see what are the actions that's being dispatched, and you can have this now dev tool for that. So that's great. Here we also create our own enhancer, which is a current function. And this is when they're starting to see all of these particularly functional concept and functional programming concepts. That is, partial application and current function are just specialization techniques. What does it mean is that you giving a particular input, you're gonna get is now a specific output. Pretty much like an assembly line, all right, that example, okay? Where the idea here is that by telling the subtle difference between compose and the compose and the partial application incurring is that you're going to pass some arguments to that, right? Unlike compose, you don't actually pass any arguments. You just let that particular functions run. They actually give you what you need. But if you want to tweak things, if you want to now customize what is the particular output of this, okay? Let's say, hey, during the example of the ice cream, hey, while putting is this ice cream, you say, hey, I want you to now to the Oreo sprinkling some chocolate, right? And just like that, right? So you have now a customized things for that. Of course, they're going to charge you more. The idea here is that this is specific partial applications and query. The subtle difference between this is that with partial application, you preset some of the arguments and later on the rest of it. So anytime you call this function, you can pass is a preset of arguments. The next partial application, the next function you call, you're gonna pass is the rest argument, and so on and so forth. Curring say, don't pass me anything at the initially. You're gonna pass me is one single input every time you call me, right? So one input, one output, one input, one output, one input, one output, one input, one output. This is something for the developer experience much more easy to reason about. But most of the time you're gonna find is in libraries and that kind of thing, using more like loosely curring, right? Which is instead of passing one argument, you're gonna pass it several ones. But the point of this is now we are actually having these specialized functions, which is especially when you want to now return a specialized store that contain now this, for example, logger. Anytime an action is triggered, you want to know what's happening there, or anytime you are now updating the state, okay, you want to measure that. You want to now is put some dev tool as a way to know which actions are dispatching. So this is now this particularly specialized things that you want to now return here. This is very interesting, this particular approach. And unlike middlewares, which now intersect is the process of dispatching, so it sits between the dispatch as well as the reducer. Unlike the enhancer, it runs initially. It runs on every dispatch process. Sorry. So you have now is the dispatch action, okay, that you can now here in this middleware receive is this particular function. So let's go to this example, right? Because once we are creating is this, especially in enhanced or middlewares, thumb exercise middleware. I didn't put this middleware. No, combined reducer. Interesting. Okay, let's going to create that example here with middleware, right? Yeah, let's going to create that example here with middleware. Log me. There you got it. There you got it. Okay. Now let's define a middleware. So this middleware, what it does is to now intersect is the dispatch between the dispatch and the enhanced, the dispatch and the update logic, right? So it runs every time the dispatch is triggered middlewares. So here the most common use case is for log the activity of these dispatch actions, as well as log the user activity when you navigate to a particular place, and also when you want to is when you want is to okay, that's right. So with this middleware, it's something that you can, of course, intersect that actions and do something about it. Hey, I want to now log the user activity when navigate to a particular page. Also log the action that is being triggered. Or here's when the interesting things kicks in. You can now is separate the async logic, right? You can separate the async logic, and once you get that data from this async logic, it can be some user inputs, or waiting for user inputs or computer inputs. User input is like waiting for the user typing here, scrolling, moving the mouse, or in the case of computer, it's like waiting for a image to be loaded, or waiting for data, waiting for the data from the server. So fetching data, all of this async behaviors. Okay, now you can put this into a middleware, and when you get that data, now you are going is to dispatch the update logic, right? So the idea here is, by following is the Redux, is to understand that particularly separation of concern of why we are doing the thing that we do, because most of the time when we understand this, a lot of this is the best way of how you can move on and push forward to what's next. So yeah, we got this, all right? And here is when we come up with some interesting questions. Oh my God, here we go. So, let me actually, yeah, this is the middleware. There is also here a middleware exercise here. Yeah, this is when a particularly, wait, what? Why so fast? Exactly. I can hear you.
So I wrote the log middleware. What I want you to do is now take our enhancer from before that monitored performance, and let's turn that into a piece of middleware. And then all we have to do is add it to this apply middleware as a second argument, and we should have both in place now as middleware instead. So I'll give you.
It's not that hard. Is you want to turn this into that? Well, you can say is now log the. Well, you can say is this is, well, this is part of the example. We're going to now instead of actually putting here, okay, this monitor enhancer, we're gonna now define is the monitor middleware. So anytime an action is dispatched, I just want to actually is right.
Do is add it to this apply middleware as a second argument, and we should have both take our enhancer from before that monitored performance, and let's turn that into a piece of middleware. And then all we have to do is add it to this apply middleware as a second argument, and we should have both in place now as middleware instead.
Well,
I'll give you 5 minutes to do that.
Well, but
so I wrote the log middleware. What I want you to do is now take our enhancer from before that monitored performance, and let's turn that into a piece of middleware. And then all we have to do is add it.
Okay, so what we want to do here, assuming here, is that we want is to now measure is how long a middleware, how long this intersection, how long is this action takes. So here, based on that logic, we say, hey, middleware, or we say monitor middleware, right? Monitor middleware, and here you say, well, because this is a middleware, we're gonna get is the store. Specifically, what we're gonna get is the get state and the dispatch, right? So we get the store. As you can see here, we actually is in this case is also a current function as well. You're gonna get this function, and then you're gonna call another function that actually provide you is the next, which is part of the middleware value as a way to trigger this, the next action. Okay, so because middleware intersect is the dispatch actions, and is triggering any time you call that function. Well, the idea here is that you need to actually find a way to run that function. It's like, hey, I am in the middleware, I intersect this, now I need to let that action happen, which is with next. And we're also gonna get is the actions, right? You can see here we're actually is using is this current concept. So all of these now specific functions that are giving, all of these functions that which output are giving is a specific or a specialized data. Okay, we are going to actually is do the same here. So here we're gonna say, hey, console log, we can say is time, because we want us to monitoring is time, right? We're gonna say star, but here I want to now is check the performance now, and then assign that to a variable here called star. So I want you to store JavaScript. I want to store this as star. Okay, console.log that as fast as possible. Console.log, so you say star. I think this is, how can you say, is that initial, so start time middleware, right? Middleware, right? And then you got this, my bad. Okay, then you have then you want to actually trigger the action. Okay, so it's a, hey, please trigger the action, whatever action it is, and after that I want to also know is the end of this, which is great. This is quite interesting because here we can now not only have access is to the current state, the old state, and then the new state as well, similar to this, right? You get the old state and then you get the state as it is. So we can say end, right? You say performance dot now. Okay, pretty much is doing this. Okay, right, there you got it. The only thing that we're gonna change is that this is end time middleware and the end. All right, and that's it. And that's it. This is it, right? And when we're going to now use the apply middleware API that allow us to actually put all of this function that sits between the actions and the updating state, right? They're gonna sit between them, so you can now have access, or so we can now run this particular series of functions. In our case, you're gonna run the logger and then the monitoring. But in this case, it's gonna run is now the monitoring and then the log state. So yeah, this is interesting. This is interesting. This is quite okay. This is quite interesting. I'm sorry. This is not. I mean, you can't turn this into a curring function. This is not a curring function because we're not returning something. Unlike enhancer, we are returning is now a specialized object, specialized output. Here we're not returning that. I mean, you can, but in this case, it's not a curring function. Anyway, here we are, right? Instead of saying this, compose this, apply middleware, log middleware, right? Similar to the monitor middleware, monitor middleware. That's right. We're passing that as a reference, and then when we reload this, we say, hey, let me actually run. Okay. This is actually to take that thumb exercise. That's right. Yep. Good. We actually run this, and there you got it, right? So once we take a look at this, as you can see, is that. So that's right. It's actually quite fast. Performs.now. That's right. Exactly. So wait for you to, so you can see that, right? This is now part of the exercise. And there you got it. So this is part of the exercise. And middleware exercise, right? It's like this. And there you got it. Okay. All right. Middleware exercise. So the idea here is to log state reducer. That is your enhancer. I don't want to pass here any log enhancer. Okay. It's just this. Wait, what? Oh, exactly. I just removing is the enhancer here, like that. Only the log and monitoring that's it. I don't need to actually pass any enhancer to that because I don't want to. And then apply the reducer, and then you got the log middleware and monitor middleware for that, and that'll be here, right? So that was quite interesting, right? This is the output here, so we can see this. All right. If I say this, so a way to only show is the relevant data. Reload the site, please. Be my guest. Right, and there you got it. Right. Okay. Please, I want you to now is only remove the enhancer. Right. Move the enhancer here, followed by this as well, and that's it, right? This is what I want you to do. Okay, bring that here, log middleware, exactly, and the start middleware as well, right? So yeah, this is it. And there you got it, right? As you can see, as you can interpret the output of this, all right? When you got this log middleware here, right? And then start time and end time, okay? And then you got now the end time, which is quite interesting. Which is quite interesting that it does this in this particular way. Exactly. Okay. Now this is the output, bro. Say, hey, what the French toast is this? Now this is the output, the proper output. So okay, good. So start time, end time as a way to measure that is quite fast. Similar to this time was quite fast as well, and so on and so forth, right? This is something interesting. As you can see, this middleware is triggering is from right to left, depending on how do you define this, because it's triggering is okay from left to right. This middleware is getting triggered. Interesting. Composed to the opposite, but now apply middleware is from left to right. All right. So it's triggering is this log middleware, start time and end time, and then the log middleware, because we are updating is that. Again, we're triggering is that, and there you got it, right? So, this is something interesting, all right? But what happened when we want to, for example, is, because this is now the use case, right? We're gonna put this, right? So far so good, but this is quite interesting. It's like, okay, but what happens when we need to actually deal with this async nature? We are in the realm of JavaScript. We want us to not, we're in the realm of the browser or in the JavaScript environments. And here we need to actually communicate with other systems, with external systems. Okay, not only your main memory or your disk, but also other computers, miles away. How can we do that? So middlewares also help you here to not only handle this use case for logging the user or logging the user activity as it navigate to, so logging actions as well, and performing side effects here. Not only like routing, but also is turning the async API calls, right, into a series of synchronous actions like this. So in this particular case, because we were able to do that, right?
So our mission was to simply just create a second piece of middleware, predominantly to see how you can actually chain multiple pieces. The way that I remember that both again, where we get the performance monitoring as well as the state changes. So really, all apply middleware is this abstraction over enhancers that involves less boilerplate for you to write and is chainable out of the box, and it creates one enhancer out of all of the middleware and is useful for kind of either having side effects around the flow of actions, because even as we said in the very beginning of this, a reducer is a pure function that takes two inputs and makes one output. It should theoretically not have side effects. We have all put console logs inside of our reducers. But in terms of things like you can't necessarily make those actions, you can replace them and dispatch new actions. If you did not call...
So with this here is unlike enhancers, okay? And unlike enhancers, all right, and you can change here. So you can change middleware easily, right?
All next.action based on some kind of conditional, it would never make it through the rest of the middleware and to the reducer. Sometimes that's what you want. Sometimes you're letting someone dispatch a function, you don't want to make it all the way to the reducer. You want to go make that AJAX request, do whatever, wait for the promise to resolve, get that result, and then turn that into the action that goes to the rest of the chain. Middleware is the place to do that of the Redux. And so at that point, like, congratulations, you can like print out a certificate and put it on your wall. You now know the entirety of the Redux API. That is all. We covered all 5 of the methods. We covered all 4 of the ones on the store. We have gone through all that there is to know about Redux. The next step for us is to figure out how to put it into a React application. All right? And so what we'll do is we'll take really 3 different approaches. We'll use hooks to just hook our Redux store up to React at all. Right? And then we'll figure out how to get state and dispatch actions from our components using hooks. And then we will look at how to do it using higher order components. We'll talk a little bit about what strategy you might want to use and why. And then finally, we'll take a look at it using Redux Toolkit, which will wrap a lot of this up for us. And we'll use hooks to just React application. All right? And so what we'll do is we'll take really 3 different approaches. We'll use hooks to just hook our Redux store up to React at all. Right? And then we'll figure out how to get state and dispatch actions from our components using hooks. And then we will look at how to do it using higher order components. We'll talk a little bit about what's
higher order components. Okay.
Strategy you might want to use and why. And then finally, we'll take a look at it using Redux Toolkit, which will wrap a lot of this up for us. All right. And so what we'll do is we'll take really 3 different approaches. We'll use hooks to just hook up.
Okay. So now this is the next section. But we think when we look at this at this async approach, which say is like, all right, this is great, this is good, but when it comes to actually now dealing with async nature, how can we do that? We need to know things in terms of how can we deal with this kind of Redux application, especially if you are now if you're going to provide your service to a company that actually is selling smart TVs or that are selling cell phones to celebrities, and one of them actually purged, say, Kim Kardashian or Kanye West actually buy that latest mobile, all right? And I get why they don't use is the Apple example, but in any case, the idea here is that if you are now going to define as an e-commerce, where the hardest part of all of this is to now the handling is the async logic here, which is the checkout button. And let's say you implement that, you are relying on a third-party library to do this, and then, well, finally, good, everything is good. So yeah, it's like, and then you receive now a call Saturday 1:50 a.m. that say, hey, from the CEO, and say, it's like, hey, we got a fire here, and we need you to handle this because we charge is to Kenny 5 times the same smartphone, iPhone. So even though that we can pass through all of this credit card things that you say, hey, I want you to recharge that because we are actually resell that too many times. That's not a problem, but we want to prevent that. How can we do that? So then you as an engineer, you have to say, okay, so let me now go down on how it's being done, because I'm relying on this particular library, right? Okay, so then you go now to your code, you analyze that particular third-party library, what is going on, and then you say that, hey, the way how it's handling asynchronicity is kind of funny, because it makes some sort of assumptions here. Like, hey, if you don't receive a particular time a good response from the credit cards company, then I want you to retry that, and retry that. So there's actually no way of how you can actually wait for that response to be complete. And that's when you get into trouble, because if you say that to the CEO, and then he say, all right, what happened? Now the problem was on a third-party library that was handled that. So we actually, they actually need to handle that. I already had a contact with them, to the HR, and to the maintenance to actually fix that particular issue for that. And then your boss wouldn't be happy to hear that. It's like, it's gonna ask you a lot of questions. This is when you want to hide yourself behind this. Then see is, you wanna. This is when you show up. You accept your failures, all right, and you now act accordingly. You say, hey, the next time we're gonna see if we can need to implement our own solution. And because of that, implement your own async solution, you quickly realize that it's not that easy as you might expect. Okay? And that's when you say, hey, let me now actually take the course from Kyle Simpson as a way to, well, understand now what are these async patterns here. All right, what are the async patterns that exist right now? How can that solve our own problems, and understand that? So one of the things that as we get into the thunk, we need to is understand is did I put it here? No, not really, right? No. Okay. No problem. So JavaScript, our good old friend, rethinking here. On rethinking here. So what's a thunk? Okay. So what's a thunk? All right. So from the sync POV, this is a thunk, and from the async POV is this one. This is the thunk exercise. This looks like a problem. This is what we're going to look at. Resync is this. Rethinking asynchronicity in JavaScript. So again, the goal of this particular course, right, is to be able to describe quickly all of these async patterns. And by pattern we mean is that typical solution to common problems, asynchronicity, right? And how now each particular pattern actually provides some of the goodies and not that. In other words, it is a trade-off. And the idea here is to, as we look at each one of them, understand that when we're writing code, we want us to write this code similar as the JavaScript allows to do, which is line by line, as a single thread. Is go one line, so evaluate one statement and then the another statement and the other, because the moment when you starting to diverge your thinking from the JavaScript engine, that's where the bugs happen, especially in asynchronicity, especially in this asynchronous environment. So understand now how this particular pattern actually solve our own problems. A lot of the time can now give us insights, understanding some of the important part of all of this. It has to be genuine, and that's the reason why we are going to look at this, right? At the parallel versus async. Let me see that. That's right. Which is this particular course from Kyle Simpson. Why we want to do this? Because we need is to not only understand these particular patterns, be able to describe that, getting a hands-on approach, but remember the thing here is that understanding is these concepts, the fundamental concepts, be able to articulate that, be talked to, and then practice of why we do why we do the thing. So, because of that, all right, we looked at this is the agenda
this idea
here.
of concurrency. What does concurrency mean? A lot of people would think concurrent means two things happening at the same time. Again, it's one of those things, if you squint. All right, so let's jump in. Let's talk about parallel versus async. Metaphorically, if we try to understand what parallel is versus async, most people conflate those and think that they're basically the same thing, or JavaScript's version of parallel is called async or whatever. It's not really the case. Only at the highest level, if you really squinted from 50,000 feet up, might you look at parallelism and asynchronicity and say they're the same thing. There's important differences. So let me give you metaphorically how to kind of play or work through that. Parallelism versus non-parallelism, which we'll sort of group asynchronicity into non-parallelism for now, and I'll explain that more. So non-parallelism would be like you waiting in line at a amusement park for a roller coaster. Lots of people in line, and you finally get up to the front of the line. There's a roller coaster there with 30 seats on it, but they only let you on. And you're the only person that can ride at any given moment. So even though there's capacity for 30 people to ride, at any given moment, only one person is riding the ride. That would be non-parallel. We'll give those different terms in a moment, but it'd be non-parallel. Versus if you waited in line, you got up there, and then 30 people loaded onto the roller coaster, and when the roller coaster is running, all 30 of you are experiencing the roller coaster at exactly the same instant. That's more parallelism. So in a computing sense, parallelism is expressed through threads, most commonly expressed.
Interest. Expression here. Parallel versus async, right? Okay, here we go. Parallel versus async. So this is now what we're going to talk about here. Parallel versus async. So parallel versus async. Right? Take a look at this. Is this one? So yeah, this is one of the idea of the parallel versus async, and how the parallel is not async, and how parallel can be non-parallel. Okay, and the idea here is that parallel is that when you go to Six Flags, and you now have 30 tickets or 30 slots, which is something that I don't know how you describe.
They only let you on.
Okay, well, there is a roller coaster. Okay, so you go to the Six Flags, and there is a roller coaster that only have is 30 seats. Okay, that you get in. So this is now 30 people that can now experience that at the same time, right? However, if you have now and the other is that even is when that capacity is reached, now you have to wait for it. And this is when it comes now to the non-parallel asynchronicity.
And you're the only person that can ride at any given moment. So even though there's capacity for 30 people to ride, at any given moment, only one person is riding the ride. That would be non-parallel. We'll give those different. Person that can only let you on. And you're the only person that can ride at any given moment. So even though there's capacity for 30 people to ride, at any given moment, only one person is riding the ride. That would be non-parallel. We'll give those different terms in a moment, but it'd be non-parallel. Versus if you waited in line, you got up there, and then 30 people loaded onto the roller coaster, and when the roller coaster is running, all 30 of you are experiencing the roller coaster at exactly the same instant. That's more parallelism. So in a computing sense, parallelism is expressed through threads.
Mm-hmm. So in a computer sense, parallelism is expressed in threads. Okay.
Most commonly expressed through threads. The idea that I could have one thread on one CPU core in my system and another thread.
Mm-hmm. So one thread on my CPU.
They're kind of like queues of actions that need to be happening or operations that need to happen.
Mm-hmm. So one thread on my CPU and another thread. So they are kind of queues of operations, right?
Happen. At any given instant, one core could be doing one of those operations, and at exactly that same moment, another operation could be happening on a different core. That's true, honest-to-goodness parallelism.
Exactly. So they're kind of queues operations. When one operations in a thread run and another ops run in another thread, so that's truly parallelism. Parallelism. Oh shit. Parallelism. Okay. Parallelism. Makes sense. Okay. Good.
Now, even with the most powerful of the machines that you may have out there, you may have a 16 core, maybe you have a 32 core, most of us probably have 4 or 8 core.
Exactly. So even so the most powerful machines, 2024, with 16 or 32 cores, makes sense.
Cores in our computers. 32 threads is not nearly enough to run a modern operating system with the types of the multitasking that we do with.
Exactly. 32 threads is not enough to run a multitude of tasks in an OS. Oh my God, yeah.
With running all the programs that we run. Even your browser, your single browser might take up 10 or 15 threads just for basic operations that it does on a web page. So if you've ever opened up the task manager of Chrome and seen all the processes that are running, you know it runs an awful lot of stuff in parallel.
It's running a lot of awful stuff. So 32 is not enough to run a multitude of tasks in an OS. Even your browser can use is like 15 threads to run basic stuff. So if you open your manager tab or your admin tab, yeah,
just for basic operations that it does on a web page. So if you've ever opened up the task manager.
Exactly. If you open the task, if you ever open your task manager, Chrome task manager of Chrome, you're gonna see a lot of
manager of Chrome and seen all the processes that are running, you know it runs an awful lot of stuff.
So you will see a lot of running process. It runs an awful lot of stuff in parallel, and runs it a lot of awful process and runs a lot of awful process in parallel, stuff in parallel. Yeah. So Firefox, for example, got over 31.5 million line of code. So you can now see that creating a browser is not something trivial, right? That's right. Creating a browser is not something trivial. And this is just one application. And this is just one application, right? So you can imagine. Imagine what an OS needs to, right?
In parallel. So because we don't have infinite numbers of cores, the operating system actually has a layer that we would call sort of virtual threads. And it takes care of scheduling the virtual threads. It can hand out tens of thousands of those. And it takes care of trying to schedule those across the core so that they're happening as in.
Exactly. So the virtual threads are a way of how the processors can handle or can pass over, can delegate all of more tasks and schedule them. Yeah, exactly.
As much in parallel as possible. From the perspective of your programming, you don't really care about that or even know what cores they're running on. You just assume that these two things are on separate threads, that the operating system will do the right thing and make sure that they're running separately. All right, so obviously parallelism is about optimization, right? If I've got a bunch of things to do.
Mm-hmm. So as a JavaScript or as a developer, you just give this thing by settle. So parallelism is about performance. You wanna do the most amount of tasks at the same time. Right? Good.
I don't want to wait to do the second set of tasks until the first set of tasks is finished. If it's possible to do both at the same time, if I can get done faster, that's much better. Parallelism is about optimization. All right, so if that explains parallelism, what about asynchronicity? Well, asynchronicity, the world that we live in asynchronicity, moves us to a single thread. The programming inside of our JavaScript runs entirely on a single thread, even though the browser may have access to multiple threads, and even the JavaScript engine, Node, for example, could use hundreds of threads in the background, but our program only runs in a single thread. At any given instant, there's only one line of JavaScript running in the JavaScript engine. You could, in theory, spin up multiple instances of the JavaScript engine on entirely separate threads. And yes, that would look like multi-threaded programming, but they couldn't communicate in any useful way.
Mm-hmm.
Web workers is an example of trying to bridge that gap. Web workers is a way of spinning up an entirely separate thread, but that's not a JavaScript thing, that's a browser thing. The web platform defines the notion of web workers, spins up in a whole separate thread, a whole separate instance of the JavaScript engine. As JavaScript is concerned, those two things don't know about each other. They don't have any overlap. They're not sharing variables. There's nothing. The good news is we don't have to worry about any of the nonsense that threaded programming has to worry. We don't have to deal with mutexes and semaphores and all that other craziness and shared resource locking. The good news is we don't have to separate instance
Oh my
of the
God.
JavaScript engine. As JavaScript is concerned, those two things don't know about each other. They don't have any overlap. They're not sharing variables. There's nothing. The good news is we don't have to worry about any of the nonsense that threaded programming has to worry. We don't have to deal with mutexes and semaphores and all that other craziness and shared resource locking. We know that
Share resource locking, bro. Holy crap. The lock statement, locking mechanism on shared resource in JavaScript. Share resource locking in parallel. Locking shared resource and threads.
only one function can be running at a given time. And if you have two separate JavaScript engines running, it doesn't matter because they're not going to be operating over the same shared space anyway. Now, web workers fortunately do give us a communication path through asynchronous events. So even though they are functionally operating on independent threads, they cannot communicate in a threaded fashion. They have to communicate back on that single threaded notion through the event loop. Runs entirely on a single thread. Even if it's finished, if it's possible to do both at the same time, if I can get done faster, that's much better. Parallelism is about optimization. All right, so if that explains parallelism, what about asynchronicity? Well, asynchronicity, the world that we live in asynchronicity, moves us to a single thread. The programming inside of our JavaScript runs entirely on a single thread, even though the browser may have access to multiple threads, and even the JavaScript engine, Node, for example, could use hundreds of threads in the background, but our program only runs in a single thread. At any given instant, there's only one line of JavaScript running in the JavaScript engine.
Exactly.
You
but
could, in
this
theory,
is something relevant for ourselves because after all, we are JavaScript
runs entirely
developers.
on a single thread. Even though synchronicity, the world that we live in asynchronicity, moves us to a single thread.
Exactly. So the world of asynchronicity move us to a world of single thread. Makes sense? Single thread, right? So the world of asynchronicity move us to a world of single thread, right? So where the idea is to run a program on a thread. Okay. The idea is to write a program in a single thread.
The programming inside of our JavaScript runs entirely on a single thread, even though the browser may have access to multiple threads, and even the JavaScript engine, Node, for example, has.
Exactly. In our case, JavaScript. Even though the browser use multiple threads, we can now in JavaScript run code in a single thread, which means that we have to wait for it.
Could use hundreds of threads in the background, but our program only runs.
Exactly. But now in our JavaScript program, it runs in a single thread.
Runs in a single thread. At any given instant, there's only one line of JavaScript running.
And at any given instance, there is one just JavaScript running.
In the JavaScript engine. You could, in theory, spin up multiple instances of the JavaScript engine on entirely separate threads.
Exactly, which is something that Node actually does. So you can, in theory, spread that.
One line of JavaScript running in the JavaScript engine. You could, in theory, spin up multiple instances in a single thread. At any given instant, there's only one line of JavaScript running.
So, in any given instance, you are running one JavaScript code. You're running is just one JavaScript, one line of JavaScript
in the JavaScript engine.
Exactly. And at any given instant, you're running one line of code or JavaScript code in the JavaScript engine. Okay, so this engine, this person that you can imagine, is like only processing is one statement at a time.
You could, in theory, spin up multiple instances of the JavaScript engine.
You could, in theory, spend multiple. You could, in theory, spend multiple process
on entirely separate threads. And yes, that would look like multi-threaded programming, but they couldn't communicate.
Exactly. So in theory, you can spread those instances per threads or cores and simulate parallelism. Okay, but they can communicate each other. They can communicate each other. This is if you want to run out
In a
this
useful way. Web workers is an example of trying to bridge that.
So web workers is an attempt to close that gap.
That gap. Web workers is a way of spinning up an entirely separate thread.
Exactly, spinning an entirely separate thread.
But that's not a JavaScript thing. That's a browser thing.
The spin up. Okay, web workers is an attempt to close the gap by spinning
Web workers is an example of trying to bridge that gap. Web workers is a way of spinning up an entirely separate thread. But that's not a JavaScript communicate in any useful way.
Spinning into an
Web workers is an example of trying to bridge that gap. Web workers is a way of spinning up an entirely separate thread. But
web work is an attempt to close that gap by spinning an entire new process on a thread. But that's not JavaScript. That's a browser thing. That's a browser or Node thing. So in the context of Node that you can use now, that's web workers, right? So for example, is the workers, right? Workers. Interaction with workers is interesting. Interaction with workers, interesting. Is that? So they spin up this separate process as a way to communicate with others. Holy crap! Oh my God, I get it. Oh crap, nigga. Jesus. Okay. As a way to close that gap. Jesus. As a way to close that gap. Jesus. Oh my God. God damn it. Oh, interesting.
that's not a JavaScript thing. That's a browser thing. The web platform defines the notion of web worker.
The web platform defines the notion of a web worker. Interesting.
Spins up in a whole separate thread, a whole separate instance of the JavaScript engine.
So spin up a whole new process on a new thread, on a separate spin up a new process on a thread. Spin up a new process on a thread of the JavaScript engine. So when you so the browser, the platform is say, hey, if you wanna use workers, what I'm gonna do behind the scenes is say, hey, processor, spin up this JavaScript, spin up this particular process in a thread, in your threads, right? Spin up this particular process in your threads of the JavaScript engine. Holy crap! Okay.
As JavaScript is concerned, those two things don't know
Those
about
things
each other. They don't have
matter,
any
exactly.
overlap. They're not sharing variables. There's nothing. The good news is we don't have to worry about any of the.
So, as long as JavaScript concerns, they don't know about each other programs, right? So the good news, we don't have to worry about that. So the good news is that we don't have to worry about this.
JavaScript engine. As JavaScript is concerned, those two things don't know about each other. They don't have any overlap. They're not sharing variables. There's nothing.
Of the programs, so they are not sharing variables. So they're not sharing variables. They don't overlap each other. They don't overlap each other. But this is now it's an environment thing. It's a JavaScript environment thing. It's a web platform in our case.
The good news is we don't have to worry about any of the nonsense that threaded programming has to worry.
So the good news is that we don't have to worry about threads programming and thread programming, parallelism. The other is thread block communication. Deal with new taxes and thread programming, parallelism, thread programming, semaphore, deal with new taxes and semaphore. New taxes and semaphore. New taxes and semaphores. Okay. Semaphores don't have owners. The all new thing. Semaphore stacks and business solution. Semaphore stacks, but this is for the multi-threading. Multi-threading for beginners. No, but I'm looking at this. No, but okay, multi-threading programming. Semaphores. Okay. Great, good, awesome for Oracle. So Oracle knows why he's shit. Programming with synchronization objects, semaphores. Chapter 4. Okay, with semaphores, read and write logs. Programming with synchronization objects in multi-threading programming. Jesus. Okay, with semaphores. Converging multi-threading basics. Threads create attributes. Programming with synchronization object. Semaphores. Read-write log attributes. Read-write log attributes. Programming with operating environments. What the heck? Chill, bro. Chill. With semaphores. Oh crap. Synchronization with semaphores. Interesting. Semaphores. Holy moly. Okay, semaphores. So new taxes and semaphores. In block.
We don't have to deal with new taxes and semaphores and all that other craziness and shared resource lock.
Share resource locking and all of that wildness. Okay. Semaphores.
We know that only one function can be running at a given time. And if you have two separate JavaScript engines running, it doesn't matter because they're not going to be operating over the same shared space anyway. Now, web workers, fortunately, do give us a communication path through asynchronous events.
Mm-hmm. So, fortunately, web workers give us this communication step using event, right?
It doesn't matter because they're not going to be operating over the same shared space anyway. Now, web workers, fortunately, do give us a communication path through asynchronous events.
Mm-hmm. Give us this communication step through asynchronous events. Interesting. As a way to
So even though
share. Oh my god. Oh my god. Oh my god. This is experimental, bro. This is way experimental, man.
Are functionally operating on independent threads. They cannot communicate in a threaded fashion. They have to communicate back on that single threaded notion.
Mm-hmm. They have to communicate in this event loop notion. Interesting.
Through the event loop. That brings us to this idea of concurrency. What does concurrency mean? A lot of people would think concurrent means two things happening at the same time. Again, it's one of those things, if you squint at it, you might say, yeah, okay, maybe they're kind of like the same, but there's an important nuanced difference here. And by the way, if somebody wants to object to my particular usage of the words, there's actually lots of different meanings for these words, and it's hard to nail down one particular thing. So I'm trying to be as consistent within my own usage of these things. But there's actually, if you go and read Wikipedia pages or other texts on it, you'll find a whole range of different opinions on these things. But my way of explaining to you what concurrency is, rather than saying with parallelism, two things are happening at the exact same instant, I would describe concurrency as two higher level tasks happening within the same time frame. So rather than an instant, we're going to look at a time frame, and we're going to say within this time frame, two higher level operations are going to occur. To understand
instead of the instant, we're going to do at the time frame.
the notion of higher level items or higher level operations occurring, we also have to understand that higher level, or what I might call like macro level tasks, can be broken up or thought of as being broken up into micro level tasks. So here's a way to visualize the macro level and the micro level and how these things might go together. So on the left-hand side, we have this yellow-orange task, with macro level task, which is broken up into those individual numbers, 1, 2, 3, 4, which would be micro level tasks. These are my made up terms, these aren't official terms, but macro level and micro level tasks. Okay? And then on the right hand side, we have another macro, which would be together. So on the left hand side, we have this yellow-orange task, with macro level task, which is broken up into those individual numbers, 1, 2, 3, 4, which would be micro level tasks. These are my made up terms, these aren't official terms, but macro level and micro level tasks. Okay? And then on the right-hand side, we have another macro-level task represented by that blue-green color, and it's broken up into 3 pieces, 1, 2, 3. Now, for the easiness of math, I'm going to pretend and assume that each one of these micro-level tasks takes 1 full second to complete. So this overall system, to do all of the tasks, it's going to take 7 seconds. Does everybody agree with that? Because it's a single-threaded system, nothing can happen at exactly the same moment, so those 1 second micro-level tasks are going to have to be scheduled in some way that all 7 of them finish, and that's going to take 7 seconds. Let's pretend that the yellow-orange represents an AJAX request and response cycle. Fire off a request, we get a response back. And let's pretend that the blue represents a scroll, that we scrolled on the page and it repainted everything because we scrolled to a new location on the page. These two operations have to fundamentally happen on the same thread. The entire user interface of our browser is happening on the same thread. So our JavaScript, the garbage collector, the style engine, the repaint, everything, it's all happening on one thread. Which means we kind of have to worry about contention. And if you've ever had an animation on your page have jitter in it, you know why that happened? Because something contended on the UI thread. At that moment, your CSS engine was trying to, or your layout engine was trying to repaint the page, it's 60 frames a second way that it's repainting your page. It tried to do that, but at that exact moment, something else was running. So it had to wait an extra moment, and that's what created that jitter. Single threaded. So if we have these higher level, macro level tasks that we want to happen concurrently, I want the yellow and the blue to happen at the same time. Why? Well, let's imagine they don't. One way of scheduling this system, one way of scheduling this program, is to do all of the yellow first and then all of the blue. What would that look like on our page? Ignoring the 1 second thing for a moment, what it would look like on our page is that it would look like I clicked the button to make an AJAX request, and while that was happening, I tried to scroll my page, but everything was completely frozen while that happened. And then after it finished, then it sort of, jumped back and caught up. We actually have precedent for that. It's called synchronous XHR, synchronous AJAX. One of the worst evils perpetrated upon the web platforms. It's a terrible idea. There are people out there that are crying and literally complaining on standards lists saying, how dare you take away my synchronous XHR? It's been deprecated and removed from the web platform because it's a really bad idea. It's a terrible idea to schedule it that way, isn't it? Because even though the overall system would still take 7 seconds, that particular choice of scheduling those micro-level tasks would feel terribly inefficient. Does everybody agree with that? Just from a user experience perspective. If, on the other hand, we chose to interleave these things together, where one thing might be blocking so we can do something else while one thing is blocking before it can move on to the next thing, if we chose to schedule those things in an interleaved fashion, the overall system might still, in fact, take 7 seconds. But the perception of the performance is that things are going to be happening in parallel. Really, more importantly, we should be saying those things are happening concurrently. The AJAX and request and response is happening concurrently.
Those things are happening concurrently because in terms of, instead of actually looking this as a process, as instance, right? We're gonna look at we're gonna perceive that is for the time frame.
With the repainting, even though at any given instant only one of those micro-level tasks is occurring. So it might still, in fact, take 7 seconds. But the perception of the performance is that things are going to be happening in parallel. Really, more importantly, we should be saying those things are happening concurrently. The AJAX and request and response is happening concurrently with the repainting, even though at any given instant only one of those micro-level tasks is occurring. So, just to visualize that, my fancy animation took me about 2 hours to get right in Keynote. Here's a way of scheduling those micro-level tasks onto that single thread in the middle called the event loop. I don't know why that advanced. The single thread in the middle called the event loop. That's what we call it in JavaScript. At any given instant, it's only doing one of those things. So when you have an AJAX request that comes back and you need to fire the callback for a response, if at that moment somebody's already executing, nobody gets to cut in line. Right? It's not like your response callback gets to interrupt and say, oh, it's time for me to run. You know what it does? It gets at the end of the line, just like everybody else. So when the garbage collector says, I need to collect some garbage, and the style CSS repainter says, I need to repaint the page, and the layout engine says, I need to do some work, and the JavaScript engine says, I need to fire this response callback, and every single one of them, it's a first come, first serve, everybody gets at the end of the line. That is fundamentally what the event loop is. Okay? So that's just a high-level view to help you sort out what's going on. And the main point here is that the scheduling of this is not always entirely within our control. Sometimes it's race conditions that choose one versus the other happening. Not all that's happening, but there's an awful lot of coordination necessary. Sometimes it's the coordination of when things happen, but oftentimes it's the coordination of responses to things happening. Because it's not always a very serial, like do this, and then when that's finished, do this, and then when that's finished, do that. Oftentimes it's much more complex, like, hey, go do these 3 things in parallel, and then when at least 2 of them have finished, you can move on and do this other thing, and then when that 3rd one comes along, you can branch out here and do this other thing. And before long, it's just crazy complex tree of different states of things that can happen. And it's that complexity that we have to manage in our programs. It's that complexity that begs for us to have better patterns for concurrency management. That's what asynchronous programming is, managing our concurrency.
So here we're talking about is concurrency. And that is our job here. Concurrency. Damn, son. So this is concurrency, right? That's now the complexity that we have to handle this.
Okay? So that's a motivation for you from a philosophical and conceptual basis, a motivation for why we go to the lengths that we do to try to write the programs that we do. Everything that I'm going to show you in this workshop is something that could fundamentally be done with nothing but the callback. There's no new functionality here. But we're going to see that the callbacks fundamentally are insufficient for expressing the higher and higher orders of complexity that our modern JavaScript programs are doing. Our modern JavaScript programs are falling all over themselves because we need these higher order patterns, and we're not disciplined enough to learn them and implement them. We just keep doing the same thing we've always done because it always worked, and it always worked, and it always worked. This is a call to arms to say the new baseline of competency as a JavaScript developer is to have a much more sophisticated, strategic, and tactical approach to your concurrency management, to your asynchronous program.
Because concurrency is the thing that we have to manage when it comes to provide solution to business, right? It's concurrency. Instead, instead of looking at this like parallelism, which in our case is since we are writing JavaScript programs, which means single threads, okay? Single thread applications. Concurrency is the ability to a system, at least to me, is the ability to a system to deal with work, or to deal with things that happen out of the normal flow. Is to deal with things that happen out of the normal flow. Is to deal and run with things that happen out of the normal flow. So for example, we have now I think this is concurrency. So let me actually take a look at that to ChatGPT, all right, as well as Perplexity, right? So it is safe to assume that concurrency is ability to a system to deal with a normal flow. Okay, so Perplexity here, this particular model, logging, what? Okay. Okay, then you got it. So reload, no? That's quite annoying, by the way. Oh, it's because the implement is that. Oh, 0. Of course, deal with that. Let's go to delegate that. Go back. Login. What? Why not? Why not? I am here. There's this one. What the French toast? That's right. Okay. What the hell? Anyway, here we are, right? So it's gonna ask the same thing here by saying is this one, right? Cool. Awesome. That's close. That's close. Concurrency generator refers to the ability of a system to handle multiple tasks on a process simultaneously, often interleaving then or switching between then and fiction. Instead of dealing with out of the normal floats, event specifically, concurrency enables a system to manage multiple tasks that make overlap in time, which is essential in multitasking environments or in system that responds to multiple external requests or inputs, and it can do that. So concurrency can involve that dividing tasks into smaller subtasks that can be managed in parallel. Even with a single CPU by time slicing or coordinating multiple threads or processes to achieve efficient responsiveness. This contrasts with the sequential processing where each task must wait until the previous one is complete. Exactly. So unlike sequential processing, with you have to process this and then the another one and then the another, so each one of the tasks needs to actually be processed after in a sequence. All right. Concurrency say, hey, I'm going to process. I'm going to now is manage multiple tasks that overlap in time. That is something interesting. So, okay, concurrency is the ability of a system to deal with multiple tasks that overlaps in time. That overlap in time. Multiple tasks that overlaps in time. For example, all right, when we are cooking and someone calls us, okay, and your mom calls you, so while you're doing that, so when we are cooking and your mom calls you, you deal with the cooking, okay, and as well as the calling. So, and this notion, this understanding can give you now, oh my God, this understanding can give you now that, right? So, yes, that's a great analogy. And this is important to see. According to ChatGPT, is this one, right? Because we need to define is what concurrency is as a way to now understand what are the problems that we are going to solve, especially in JavaScript applications. Concurrency is one of them. It's all of these multiple tasks that have all of these multiple tasks that happen at the same time or that overlaps in time. All right, and not only all of these tasks, we also need to have a record of all of this, right? And the state management. Okay. Okay. Okay.
And it always worked, Right? Our modern JavaScript programs are falling all over themselves because we need these higher order patterns and we're not disciplined enough. Everything that I'm going to show you in this workshop is something that could fundamentally be done with nothing but the callback patterns for concurrency management. That's what asynchronous programming is, managing our concurrency. And then when that third one comes along, you can branch out here and do this other thing. And before long, it's just crazy complex tree of different states of things that can happen. And it's that complexity that we have to manage in our programs.
Mm-hmm. Exactly. So is that complexity of dealing with multiple tasks that overlap in time. So for example, right? So for example, when we're cooking and your mom calls you, right? You're dealing with the cooking as well as the calling, right? This is known as the concurrency. This is known as the concurrency, and that's the complexity we have to deal as that. So it's the complexity of dealing with multiple tasks that overlap in time. So is that the complexity of dealing with multiple tasks? For example, when doing that, is that we have to we need to take care of. We need to take care of, right? So good. So let's go. That'll be all for this video. Take care. Bye bye. All right.